Greetings. My name is Charles Vardeman, and I am faculty in the Center for Research Computing at the University of Notre Dame. I'm also associated with the CI Compass project, and this is a National Science Foundation funded cyber infrastructure center of excellence for the major and mid-scale facilities, particularly with respect to the data lifecycle. And today I'd like to sort of give you some background on generative AI, and particularly generative AI for the what I call the working scientist or the working researcher, or facility staff that may not have had time to, really understand these things, even though they're sort of the new buzzword and everyone in the world is talking about them. And you may have, experimented with Chat GPT, but how do we start to think about these as tools to do science? And that's sort of the goal. And as part of this effort, the CI Compass is organizing a workshop, and that's what part of these videos are meant to give some background for. And this workshop is, called AI meets CI, Intelligent Infrastructure for Major and Mid-Scale Facilities. So this is, how does AI integrate into your workflows in terms of helping you to build cyber infrastructure and maintain cyber infrastructure in your data lifecycle, but also how does it, help scientists to answer questions? And these things are sort of connected together. This talk I'm giving you is actually available in Jupyter Notebooks, and so the links down below will give you a link to this GitHub repository. And so you can click on the notebooks in GitHub, and they will get rendered for you, and you can follow the links, and you can sort of see what's going on there. So all of the videos will have this link to the primary materials with the links. So as I said, the background of this is, to talk about generative AI. You may be familiar with Google's offerings in terms of Gemini, maybe on your phone or on your web browser in terms of Chrome. OpenAI started this all with ChatGPT, and then Anthropic has Claude. And then, so these are all sort of chatbot agents, but there's other ways of interacting with AI that I also want to talk about a little bit. And so in the last year, there's been the rise of these software engineering agents, and these are integrated into sort of software code environments that programmers are using quite extensively now. These encompass things like Cursor, Visual Studio Code, those sorts of tools that programmers are now using to help build code faster and hopefully better. And then there's another set of tools that sort of integrate into notebook environments. And these are sort of Gemini that's built into Google Colab. But also, there's this interface called Solvit, which is this interface that you see right now on your screen. And so Solvit is a Jupyter environment, Jupyter-like environment that provides interaction. The AI can see sort of everything in your screen. It's a product from Answer AI, which I have sort of a demo, sort of a version of right now. But these are Jupyter notebooks, and so that's the way to sort of think about how these things work. And so I will be presenting this entire series, using Solvit and sort of using the notebook environment. Okay, so where do you sort of get a conceptual foundation for how these models work and how to interact with them? And I think that a really good resource is Andre Karpathy's videos on YouTube. And he has two in particular that I think are really good. If you're a non-expert and wanting to sort of understand how these things sort of work, but not in a deep technical dive, but from a conceptual level of, how are they trained? How do these models sort of interpret the world? How do they quote unquote think? All of these sort of topics he goes into. And so I think that this is a fairly good set of videos that are going to be linked down below. So these are sort of prerequisites, I think, to understanding many of the topics that we're going to talk about in future videos. I think likewise, there's another video that he's created, which is sort of a walkthrough of how he uses this. And so part of thinking about how these models and what they can be used for and what if they're useful or not having some basis in terms of how other people use them, they give you ideas. And I found this video very useful in terms of using different models and trying out different things in different models and how they sort of relate. And so I think this is a really good foundation to think through. Okay. So I've been talking a lot about Claude and GPT and OpenAI and ChatGPT and I've mentioned Gemini, and these are what we call foundation models. And so these are large language model architecture models, but they've been trained through a certain set of processes that are enabled by transfer learning, right? And so a foundation model is essentially just a model that has some aspect of the world that it's captured, but it's the basis by which then you can do other sorts of things. And this idea of transfer learning has existed for quite a while. And so there's a couple of resources here that I highly recommend in terms of what are foundation models, which sort of goes through the various types of foundation models, in terms of diffusion models, which are used for video and image generation. There's a whole set of large language models, usually based on transform, but not necessarily. And then there's some other models. For large language models, the background on this is this paper you know from 2018, which sort of introduced the idea in that has existed for a while in image models, right? So this convolutional neural network based models using essentially a pre-trained convolutional neural network and then fine tuning it to do a specific task. So as versus starting out with a network that's completely untrained and trying to train it for a task each time. And it turns out that it's much easier to use a model that's pre-trained on some curriculum as a starting point. And so that's the basic idea for the notion behind what a foundation model is, just to give you a feel for that, right? So if you're interested, there's the sort of foundational paper, but that's the basic idea, is that you have a pre-trained model that has some knowledge in the world, and then you fine tune it for a particular set of applications, and then you can use it for that set of applications, and it's a much better approach than just starting from scratch. There's also a set of quote-unquote foundation models for sciences, right? Just to make you aware that not all of these are based off of large language models. Some of these are trying to teach fundamental physics and interactions in the world. Some of these are trying to teach cellular biology. And so it's taking that idea of having some foundation model and then maybe building another foundation model that has particular aspects integrated that then you can use as the basis for building other things. And so these are just building blocks that are neural networks that you can use for building other things. Another thing that I'd sort of like to address is that a lot of commentators and people try to think about this, and they've said, this since ChatGPT was released, is that these things are autocomplete on steroids, and that is 100% true, right? That these things are basically doing their feed-forward autoregressive networks, a lot of technical gobbledygook, but basically what it means is they're doing next word prediction, right? Based on all the other words that you fed to the model. And so, that is a good way of thinking about them. However, I'll caution the on steroids is doing a lot of work in that sentence. And so, the transformer, as you scale it, there's really interesting things that sort of happen in terms of the self-attention and in terms of how these networks work. And we really are now just starting to understand them. And so one of them is this idea of memorization versus generalization, right? And so as Karpathy says, when you're trying to zip the entire internet worth of information, right, that you're forcing the network in order to memorize that entire internet's worth of information, that it has to do some generalization, right? And so that's what this very nice graphic from essentially some work from Anthropic on these transformer circuits, and also Google has done some work, is that if you take a set of training data, right, and you start training the network, very quickly the network goes to 100% performance, right? And so it memorizes the training data very, very well. But if you keep sort of overfitting, so to speak, right, And you look at the test data. So this is unseen data that's out of quote unquote out of distribution, right? How well does it generalize, right? It basically follows this pattern of it doesn't generalize very well, and then all of a sudden there's a phase transition in the network where it then starts to do generalization, and that's what this is illustrating. And you can sort of see this in these sort of input frequencies in terms of them starting to become coherent, right? And so you sort of see this random, sort of signals that are unstructured, and then all of a sudden when you go through this phase transition, something in the network is changing, and now you see, something become coherent, right? And so we don't completely understand this, right? But it leads to properties of the network that are sort of, I'm going to use the phrase in air quote, emergent, right? And so they're not necessarily something would expect. They're a consequence of sort of scale and the way that these networks are working. There's an entire field of research called mechanistic interpretability, which is actually using techniques, in fact, from statistical mechanics, that you can actually, use some of these underlying science techniques to understand how these networks actually perform in terms of trajectories and what the underlying energy landscape, quote unquote, of these networks look like. So this is just to give you a flavor of, there are some very interesting scientific questions in and of itself, but that also leads to the concrete thing that these things are more than autocompletion on steroids, and that they have some emergent capabilities, and we'll talk about those here in some future videos. And so one of the nice things about Solve It is that it can see everything that's in the window, and I can ask it questions. And so here I ask it why this is true, right? And it says, as I said, emergence is sort of this key theme of what is this particular video, and that this idea of grokking enables the generalizations for out of distribution information, which makes them more useful than just autocomplete, because they've learned general patterns that then quote unquote autocomplete to things that they may not have seen before, right? And so this makes them very useful in a lot of different contexts. And I think that's one of the things sort of to keep in mind. So the punchline of this video is I highly recommend both of Karpathy's videos, particularly a deep dive into elements like ChatGPT. It's a bit of a long video, but I think it's quite useful. And a lot of our students have found it to be quite useful in terms of understanding how to from a practical perspective, use these things in their work. So anyway, I hope that this has been helpful. Once again, we are doing this online workshop, and there will be information coming out shortly about how to register for this if you're part of a major facility or a mid-scale facility funded by the NSF. We hope to see you there, and hope that you will participate. So thank you.